Yeah. Hello, everyone, and welcome to our first meetup. I'm really excited, and it's great to see all of you here. I am going to move to this window and start sharing my screen. So today I am going to talk to you about Java 21. It is not released yet. It's gonna be coming in a few days, I hear. And today I want to focus on some of the new features that this Java 21 version will bring, but I want to focus on how they actually improve the developer experience. That's why I picked some of the features that I think that improve the developer experience the most. So I work at IO. I work at Rabobank as IO is doing consultancy. My project is at Rabobank, and you can contact me on my website akif.dev if you want to. We can connect. I'd be more than happy to connect with you. And this will be my presentation outline. I will talk to you about three main topics, and I also added the links to the JEP. I don't know what they are called, but posts, I would say, JEP pages, and they are the official proposal pages of the JDK enhancements and new features that are added to Java. First, I will talk about something called string templates. Then I will talk about unnamed classes and the new way to write the main methods. And then lastly, I will talk about pattern matching and focus on how they apply to records and for switch statements. So let's start with string templates. Since you are here, you probably wrote some Java code, and you might also know string interpolation from other languages, because all of the major common languages that we currently use today have this feature, except for Java, well, until version 21. The features I'm going to talk to you about today are all preview features so far. There are things that had existed before as like the previous editions of the preview versions, but they keep being improved. And what a string template is a new way to basically process strings and either produce a new string, or we will see about this, you can also produce other things. As a highlight, this looks like that piece of code. What you need is something called string processor, which is this little thing here, str. I'm going to talk more about that later. And a string template, which is this part. Java parses this, creates something called string template, and processes that template with given string processor to produce whatever that processor is producing. So in here, what we want to do is that we have a variable named event with some string content, and we want to interpolate that into another string literal so that we get the expected string. This is what it looks like. And I'm going to be switching to, let me close that, my IDE. Sorry for the light theme. I don't use light theme normally, but it's easier to see during presentations. So I prepared some examples here of string templates with some tests, and I will go through them one by one. This is the example that we see from the presentation. Let me know if you are able to read, or if you want me to zoom in more, I can do that. But this consists of two parts, as I said. This str stands for string, and it is the default string processor that does interpolation. So when you do this, it just inserts whatever value that event variable has into the string literal. So the test for this one will produce this particular string, and our test will pass. We can try running the test. Let's also hide this. As you can see, the tests pass. I will come back to that later, but yeah, this is it. And this str string processor is so commonly needed that they decided to actually automatically import this. This actually comes from string template interface. There is a default instance there for the string processor, and it is automatically imported. You don't need to import that. So that's the very basic version. I have a more complicated version here. Not complicated, but it does more. It is still doing the default string interpolation, but it has now multiple types of different objects and values. And this is also an example to show you that these string templates actually work with what's called a string block. That's also some of the newer feature in Java versions to support multi-line strings and like easier use of quotations within a string literal. So they are done with like triple quotes, and I am basically doing the same stuff, injecting whatever value is in name and age, and the syntax for this string template is written like this. You have a backslash, and then within curly brackets, you write whatever expression you want to interpolate. And since things are expressions, this is actually a Java expression. This could have been extracted into another variable, given another name. This part is an expression, as I said. Whatever this evaluates to, which is if this is true, going to be this particular string, is going to get injected there. And for the object here, since the others may be trivial, but for the objects, the toString method is called here to get a value to inject there. This is like string concatenation. This behaves like string concatenation, but just as an example, I put it there. And in my test, I am passing it some object called pizza. This is a record. So in the expected string, you see a default string representation of that. Let's do something more. We only spoke about str string processor, and I mentioned that they work with string processors and templates. Java, when they added this to Java, when they were discussing this in the proposal, you can see if you go to the JEP page, they also considered, should this be only about string interpolation? Should this work in a backwards compatible way? What should be the syntax? Like many things were discussed, and in the end, they decided to make this a bit more generic, so that it doesn't only work as interpolation, but it can actually process certain things to produce a value. That's why they came up with this string processor and string template thing, and this raw string processor, which is something I imported here, unlike the str, is what gives you access to the string template that Java builds for us. And what string template is, if you go in, is just an interface that defines two important things. One is a list of fragments, and one is list of values. You can see, you can read the doc to understand it better, but I'm going to also show you here. The fragments are the string parts that are not not the values that we want to inject. So the fragments list of this string template will contain this selected portion as the first element. Then this selected portion is the second element, so on. And the values list of objects will contain this, the value of this expression, and so on. So since this string template, the raw processor gives you access to string template, you can access fragments, values, and you can do other stuff that string template allows you to. And in this particular method, I chose to call the default interpolate method. And that's going to behave exactly like what str is doing. In fact, if we go to the str object, you'll see that this is actually just a method reference to string template's interpolate method, which is taking the fragments and values and going into some implementation details, but it's going to do this basically. And as you would expect, what it does is it takes the fragment, then it takes the value, it takes the fragment, takes the value, and appends everything into building your string. So since this is how it works, you'll see the example, the same example, because it's behaving the same, is here, and that also passes. But yeah, go ahead, please. We have a question. Yeah, of course. Please interrupt me anytime.
Whoops.
Easy.
That almost went wrong. Catch.
So what are the values? Are they just like literals, or do they have like meta information, like what their name is and stuff like that?
They are just objects and they are values. So since I have the template here, and in this particular test I chose to print them out, if we look at the output of that particular test, you'll see that what is printed here is the values. Fragments are the string parts, one by one. This is the first part, as I said. Then there comes this value. This is the second part. Then that comes this value. Then the other fragment comes, and this particular value, which is what gets evaluated here from this expression.
So sadly, you don't have access to the word name or age.
You mean the name here?
Yeah, because
Yeah.
I am now tempted to write my own string processor.
Yeah.
Which would then do inference, like would think about
Yeah,
what name you used, but
yeah.
so that you can actually write macros.
I see what you mean.
You can almost build macros if they would have added meta
That would be nice. But as far as I know, you don't get access to that because this is just defined as a list of objects, and I don't think Java wraps things that it captures in something else, so you get access to those. It is interesting though. Maybe they will add that in the future. Maybe you can propose another job. Probably, yeah. Yeah. So, yeah, that's how the raw processor works. But yeah, that's still just interpolation. What else can we do? Here's a custom processor that I wrote, and I named it shouting processor because whatever it's gonna inject into the string, it's going to convert to uppercase and it's gonna shout. So if we take a look at the test of this particular method, you'll see that I'm expecting this string and whatever is being interpolated into the string needs to be uppercase, then that test also passes. How I implemented this is because this string template processor thing is an interface that has this abstract method that we need to implement. I implemented this as a lambda here, but something interesting here is that this is actually something generic. It is going to produce whatever value we say we are going to produce, And it can also fail with a certain type of exception that we define. So my shouting processor here is going to produce a string, but it can also fail with throwable. I don't think this code here actually throws in any case, but assume I implemented it incorrectly, or there is actually a case that it expects but doesn't find, you can make it throw things. So yes, but I am still producing strings. This is still not a more complicated example. So here comes another example. This is my own string processor that I wrote, and I called it welcome email processor. And what it does is it processes this particular template. It's going to produce an object of type email template for me, because it's going to extract certain things from this. It's going to prepare another string and another object that contains a string and a map of parameters that it parsed from this. What I did with this WE is just like raw. I implemented it elsewhere in a class that extends the processor, and I imported it. And just like other processors, I can just prefix my string and apply this. And what happens here with this is here. So from this string literal and the processor definition, I expect to get this particular object. This is interesting because you cannot directly see how. But if I were to go into the details and the implementation of my processor here, you'll see that this is implementing a string processor, and it is going to produce an email template object, which is a record. And this example just assumes that, well, you are using some sort of email service. You are going to communicate with them. You prepare an email content with certain parameters, with its own syntax and stuff. It's a common use case if you are working on the back end. And what I did here is, well, I grabbed the fragments and values. I parsed certain things from those. I'm not going to go into detail of how I parsed, but it's just some string processing. And I prepared certain data. And this is where I am actually forming the object that I want to return, and just extracting, setting certain things that I extracted before. So as you can see, string templates and string processors, they do string interpolation. They add this feature to Java that we know and like from other languages, but they also can do more. So any other questions about this before we move on? No? Good. Let's move on to the next one then. How many of you has ever taught Java to someone else? Yeah. Yeah, let's go back to the IDE.
What is the order of execution of processing the variables, and like when then the interpolation happens? Because basically you're saying, hey, I can provide an expression within the string template. Yeah. But then it means I can also do method calls and whatever else what happens. Yeah. What is the order of execution of like the interpolation and et cetera? So is it that if you call, for example, a string template, and then within that template you're saying, hey, I'm calling this other method, like that object, and on that object another method gets called, does that get processed first, and then the value of that being to string gets injected as a value in the the first thing. The first thing that happens is Java builds a string template object for you, just like we see here with the raw template. Java builds a string template object for you, and for that string template object, it needs the values list. So if you have expressions that need to be evaluated, if you have method calls, they will get executed first. And I am assuming it will appear, it will happen in the order they appear. So it first evaluates name
expression here, which is just a reference to the variable, so it pulls in the value. Same for the age. Then it evaluates this. I mean, we could write another test that calls multiple methods in a string template and test this, but I don't know if we will have enough time to do that. But that's my understanding, that it first builds the string template object for you. Then it passes that to the process method of that string processor you provided, which is here, by the way. I think I forgot to show that. In this shouting processor, I am still building a string template, but I'm using raw. I mean, I'm getting the string template, and I'm calling process method myself, passing it another processor. So this could be defined. This could be defined like the welcome email processor, and I could just call it. Or I think I also could do this. Yeah, this is a reference to my string processor already, so this should also work because it's no different than what I'm doing here. Yeah. Anything else? Okay. So moving on. Yeah, as I was saying, how many of you actually taught Java to someone else? Counts, but in this particular case, trying to teach Java is a better example. Yeah. Yeah, cool. Then you probably ran into this issue, especially if that person is also new to programming. Well, we all start with hello worlds, and this is the hello world in Java. It requires a lot of knowledge. It requires a lot of language concepts, and you would either tell that person, just forget about these, you'll learn them later, which doesn't help them much. Or you try explaining each concept, then they get lost already. So what they did in this JEP is that they now allow unnamed classes in Java, and also the main methods to be instance methods instead of static methods, which in turn means we'll be able to write the main method of a hello world program just like this, which is super nice because I recently studied Java with my wife who was going into this, and I did experience this. She had a lot of questions about what's a package, what's public, what's class, and so on. So yeah, this is something really nice that we are getting. In my IDE, I also have examples of this. So this is the good old Hello World program in the main, and it works. Old main and run. Yeah, it does what you expect, but now it also runs like this. Let's also try running this. Voila. And I am using an early access version of JDK 21 and also an early access release candidate version of IntelliJ IDEA. And it supports some of the features of Java 21, but this unnamed classes is not something I think it supports yet. That's why it's complaining, but it is working. I set the project. Sorry, let me quit this. I set the project level to Java 21 with like enable preview features, so it works. But I want to show you something. Because we define the main method like this, it is now it does not belong to a package now. And that is why if I take a look at the compiled version of the class, it actually sits in the default package. And this is what gets produced. As you can see, Java compiler puts what I wrote in a class with the file name, makes it final class, creates a default constructor for it, makes the main method or the other methods that I write an instance method, and then it calls this. Yeah. Probably gonna complain about main method already exists. You mean like an overloaded version?
No, in just a new file.
You mean a new file? Let's try. Yeah, then it's going to compile into new main too. Then you'll end up with two main methods. As you can see, the IDE tries to do this, tries to be smart. But if I were to try and run main2, you'll see that unnamed classes are not allowed to have packages yet, I assume, because that doesn't make much sense. However, still trying to teach this over what we are used to is still a good win, I guess. You can add the arguments, but that's also something that you are now allowed to remove, because actually I don't know what happens if I try to pass arguments to a method that that doesn't have this. Let's try program arguments. Hello world. I haven't tried this one. I still have the file, sorry. It doesn't care about the arguments. Nice.
So what is the code it generated now?
Let's see. I don't think the code it generated differs. I'm just like passing arguments to Java process, which ignores them because the main method I define doesn't take arguments.
Can you find the argument?
Yeah, I can. And if I do, what am I doing? Let's do this, right? If I do this, of course, live coding. Yeah, it works as expected. Okay.
I think the latest version of what you're running is actually out yesterday. So.
Can you use the microphone, please?
No, the IntelliJ version you're running has come out yesterday, actually.
Could be. I think things started looking much better a few days ago. But before that, when I was actually preparing the content, I saw red underline everywhere. It wasn't a pleasant experience.
But yeah. I think also the intention for the intention for this feature is also to, because Java introduced REPL like 6-7 versions ago, I don't know, where this was also like, hey, how can we help new people learn? And this is part of the whole summit, right?
Definitely. I believe this is also supported by another change that happened earlier, that Java now supports running code directly from the source code. Yeah. I mean, the Java executable, it's not Java to compile it first, it's Java, and then you pass in like -- source with the version, and then if you type the Java file name, it actually compiles and runs that. So this is also a nice addition to that. Now we are actually able to write scripts with these things. I don't think that would be accurate to say. Yeah, I don't think that would be accurate to say, but it does allow you to run things. Yeah.
Joost.
Sorry for pestering you, but I want to know what makes it tick. And so it generates a method with no arguments unless you provide it with arguments. So can you do overloading in one file with one which takes arguments and with one which does not take arguments?
Let's try doing that. Something tells me this will also work.
And then what happens if you call it with or without an argument?
Yeah. So I'm now calling it with arguments. It is passing the arguments to the method overload that accepts the arguments. And if I don't do this, always picks the one with the arguments and blows.
There is another that indicates the static a static one, and then if it's not present, it's going to fall back to another one. If not present, it's fall back.
Actually, that is probably mentioned here because there was like the launch protocol and selecting a main method right here. So if this exists as a static void method, that's going to be picked. If not, the static one without the arguments, then instance one with arguments and instance one with.
On your next Java quiz, this will be a question.
Yeah, some nice discovery. Yeah, so let's continue. Okay, we talked about this, and as my final topic, I'd like to go into pattern matching. I don't know if you are familiar with pattern matching in Java, but I prepared an example like this, which defines a language interface with certain implementations. There's a method that matches against a language object to certain patterns. There's another example that makes use of the same kind of pattern matching, but showcases the usage of that pattern in an instance of expression. There's also a little bonus of underscore here, which I did not mention, which is another JEP. And that's called unnamed variables, I guess. But let's dive more into this. So I am going to open this example and this test here. Yeah. So let's maybe start with this is Java 21 method. So what I am doing is I am passing this method a language object, and in this switch expression now, not a switch statement, because this is now producing a value, I am matching this object to a certain pattern, meaning to a certain type and values, not just values as the switch expressions did before. So what I am saying is that if this language object is in fact an instance of language.java, I mean this Java record, and its structure consists of this pattern, which is some variable called that I named version, and on top of that, which is called the guard clause, if that version variable matches this Boolean predicate, then I am producing this value. Otherwise, I'm returning false. Before going into the test and more details, I'd like to show you this one again, because that also might be something new to some of you. This is, I could not zoom in properly, did I? Okay. This is an interface, but I marked it as a sealed interface. I'll show you why in a minute. But what this means is that now that this interface is sealed, I am telling the compiler explicitly, very explicitly, that this interface can only be extended and implemented by these particular types. This allows us to do some nice stuff with the pattern matching. But what this means is that now compiler knows exactly what types this language can be, And that is why it can do something called exhaustivity check. And I believe that would be more apparent in this particular method. I'm going to remove these because they clutter. So when you take a look at this, you could ask yourself that, hey, there is no default clause here, and this thing may fail. In fact, that was true. That would be true if this language interface was not a sealed interface. So if I remove this, now my IDE and my compiler is complaining that this may not be covering all the cases, which makes sense because somebody else could be extending the language interface that we don't know. Some might even come and write JavaScript here, which wouldn't be nice. So this warning is something we may be familiar with the existing Java features, but because this interface is sealed and the compiler knows exactly which types it can be, this is not producing a warning for us because it knows exactly that we are handling all the cases. If we were to remove one of the cases, then it starts complaining again. And we could fix that with a default clause, let the compiler do its thing. But yeah, it now knows because it is able to do this exhaustivity check. But what happens if we were to introduce that guard clauses that we see here? Let's say that, by the way, this doesn't even need to match to the actual record. Let's assume that I am writing a new case where the v equals, not starts with, sorry, equals to 21, right? Then I could say 21, yay, and maybe even put an emoji here because why not? This is 2023, right? So, yeah. Now what you would expect from this method is if I were to call this method with certain values, I would get these strings, right? Let's try running this test. Patterns test, run. Yeah, things pass. But if I were to change this value, now it's going to match to another case, and it's going to fail because this is a new pattern here. But what do you think will happen if I move this pattern one line below? Yeah? You want to test? Let's see. As you can see, because of this checks that the compiler is doing, it's now giving me an error. It's saying that label is dominated by another label. That's because it is already going to match to Java pattern here, and this case will become inaccessible. This is also something nice. I wanted to show you one more thing because that's something I skipped. These are records, right? And records generate some methods for us because they are designed to remove the boilerplates. And if I define a string component like this named version, it is going to generate a method in this signature for me. And I am using this trick where I make the generated methods actually implement this method because I define the same method in the interface, and when I implement it, it is going to be implemented by the generated method. If I were to call this version 2, now it's gonna ask me to implement this method because it's extending that interface. So that's a trick. And I am mentioning this because this is named version, but I am also able to give it another name, because what I am writing here is a pattern that is matching against its structure, and I am actually assigning a variable to the first component of this record. This is called record pattern. That's the title on the JEP here. So yeah, that's also nice. But what happens if I decide to use this in an instance of? Well, I can just use the same idea. This is a method that checks whether a developer can attend a meetup, and if this is a Coven of Wisdom meetup, and the developer object matches to this pattern, and here's some more guard clause to the instance of usage of this pattern. And what this pattern says is that this developer needs to be of this developer type, and its address component, its second component, needs to match to this pattern, whose second component is something I'm going to call country, and the third component of the developer should match to this pattern, which is of type language Java, and there are these magical things now. They are magical because this wasn't supported in Java before, and it is coming from this JEP. You can go check it out later. And what this means is that, well, I don't care what this component is. I don't need to. Same with the city of an address, or the version of the language object. Yeah.
Have you tried decompiling this?
I have not.
Okay. I'm very curious what it decompiles into, because this is probably instance of, check, instance of, check, instance of.
Yeah, I am assuming it's doing something like this. It does a
smart cast, and it does deconstruction.
It is doing this, and then it is doing like developer.address is instance of address and stuff. We should be able to do that, yes, let's see. But I'm not sure. That's a test resource? No. Test class? No. Oh, it's under here, sorry. So this is patterns class. This is showing me the decompiled version. And yeah, as you can see, it generates something weird. This is the isJava21 method, which at least has a lot less. And let's see, this is a switch. It is matching against a pattern. It's giving a variable, and it has a guard clause. So it does almost everything. Let's see what it does. Well, it is just creating a byte for some reason, and an infinite loop, a Boolean, doing all sorts of crazy stuff, just so that us developers can have this beautiful experience. And that's what I was going for today's meetup. So thank you for bringing this up. Yeah. And there is even a case where it produces match exception. For some reason, if it fails to access the version component, which is coming from like its place in the pattern, because that's the first component of the record, and it's supposed to be a string. If for some reason it's not, and it's going to fail. And that also opens up something new, that I was able to use var here, because record patterns now also support type inference, even with generic stuff. But compiler knows that the first component of this Java is a string parameter, so that this version is actually string. And same with the stuff here. Even though I'm ignoring this, this is a string, this is a string, and this is a string. And I could ignore it like this. That's also an option, saying that there is going to be a variable here that I don't care to name. I could give it a name, just like how we were supposed to do before this JEP, and not use it. But that's issuing a warning at the IDE level because I'm not using it. But this is beautiful.
Can I go back to the switch exhaustive case? Because when you were explaining that, there is an interesting addition that Java has to be backwards compatible.
Yes.
And one of the things that it also does and compiles to is adding a null case in the switch statement,
yes.
which you can also check for.
Yeah.
So you can actually add a case null or comma case default or whatever.
Something like this.
Yes.
Should be the case.
If you don't do that, the JVM or JDK will insert throws null pointer exception for you automatically.
Yes.
To support older language, older JVMs as it were. But it is something that you can guard for as well, which is, at least I think it's a good thing to know.
Definitely. Let's assume that this is what we expect, but pass it a null object. Let's see in the test what happens. See, this pattern failed with a null pointer exception because that's not supposed to happen. If I want it to happen explicitly, I need to mark it as a different case. I could do it like default or null, I guess, if I could type. And let's like remove this case so that default makes sense. Okay. Yeah, that's right. It happens.
I think case null or default.
But I cannot combine it with null, so okay. Let's do like case null, and I will say this was null and default this for some reason.
You can combine it case null default, I think. That's what you have to do.
Case null and default?
Yeah, comma default. And then remove the
then
default.
Then remove this.
Yeah.
Yay! So yeah, this will now say default. This will now say default if I pass it. Let's go back to this side. If I pass it a null, it's going to say default. If I pass it a different Java version, it's still going to say default. Let's test. Okay, because I messed up with the other one, I guess. Yeah, I am.
Yeah, the next one.
I'm going to just remove this. Pretend you don't see that. Yeah.
Sorry. Can we get back to the other pattern matching example with the developer thing?
Yes.
Because I'm not really sure what's happening. Can you show me the developer class? Why does it make sense?
The developer class is also a record.
But it always has like an address. So what's the point of the expression?
You can immediately access a field of the address rather than having to say, oh, from the developer get the address, then from the address.
Yeah, if I do this and we can compare side by side. Yeah, this is deconstructing it to access an inner field directly within a pattern. This did not work, however. I hope it starts working in a future version of Java. I would expect to be able to write this, like this is a developer that matches this pattern, meaning its addresses country value needs to be this exact literal, and then the favorite language needs to match to this type and stuff. This is possible in Scala. This is probably possible in Kotlin, I'm not sure, but this doesn't work yet in Java. What you are required to do is add a guarding clause like this. And as I said, this is type inferred, so it knows that this country is a string. So as long as I'm adding an AND case, it's like, because these are short-circuiting things, as long as this passes, it knows that there exists a country which is a string, so I can just add a guard clause like this. Yeah. I think it's also not possible in Kotlin to do both type and value matches in a same pattern, right?
Sorry. So I could also just speak a bit more loud, right? So you can't do it recursively like you're doing here. So this is possible in Scala, but not in Kotlin. In Kotlin, you can only do the top level.
Yeah.
And I can't remember you can do literals in there. You can only do literals on the top level because I think it's sort of like recursing.
Yeah, that's immediately what I went for. Like when I was writing this for the first time, I also tried to match against the value. It did not work, and I converted it to this. But
are these features all non-experimental now?
I believe they are all still preview features. We can go and make sure. Let's open these. Yeah, this is actually delivered in Java 21. Record patterns. And pattern matching for switch was also closed and delivered in Java 21 because these things were being previewed in earlier versions already.
The underscores are still in preview.
Yes, that's also something worth checking. It is also closed.
No, in preview. As you can see, it is still preview. It is delivered in 21, but it still says preview.
Okay. Yeah. Sure.
Yeah.
And I don't think I showed that part, but I am passing these enable preview arguments to the compiler, and I am using the, let's see, I am using the Java 21 with 21 preview language level at the IDE level so that it knows that I'm trying to use those features. I first had to also go to this compiler settings in the IDE and add the enable preview and language level 21 features here. But with the IDE update that recently came out, I was able to set the language level at the project level, and it started working directly. So experimental stuff, but good stuff. I certainly prefer to write code in this way, and it's great that language now supports this. Well, thank you very much for listening. I think we are running out of time. And please find me if you have any questions or you want to discuss something else. And I'd like to finish with this page to remind you that you can contact me on my website, and this presentation and the code will be available on my GitHub. Thank you very much.